Hey guys, just math, y'all. Um, Welcome to the video. We are going to um, do the complex cube roots of I. Complex cube roots of I. Let's look at this problem. First thing we're going to do is we are going to put this in in polar form. This is not nearly as complicated as you would think because it is just one I. So if we think about this, we're going to have I is just 0 plus 1I. And when I graph that, that's 0 on the a-axis and just 1 on the I-axis. Okay, and so when I put this in polar form, because this is technically in rectangular, when I put this in polar form, remember polar form helps me to find the distance from 0. That's my r, which I can logically see that r is going to be 1. And then my angle, which again I can logically see is going to be 90 degrees. But we will actually go through the motions of doing it so you can see that that makes sense. So we're going to do the r. So r is the square root of 0 squared plus 1 squared, which is the square root of 1, which is 1. Logically, I just decided that. And then theta is the inverse tan of 1 over 0, which is undefined. And so again, where is the tangent undefined? Well, the tangent is undefined at 90 degrees, or technically to 70, but when we graph this, we are looking at 90 degrees. So there we go. We have our r and our theta. So our complex number in polar form is going to be 1 cosine 90 plus I sine 90. So that is it in polar form. So that's the first thing we do. Now we want to do the cube roots of this number, and of course there are 3 of them. And so we're going to use our formula from the previous slide, and we're going to do the first one. There's 3 of these. So the first one we're going to do the cube root of 1, and then we will do cosine of 90 divided by 3 plus I sine 90 divided by 3. That's the first one. And so I'm going to go over here this way. 90 divided by 3 is 30, so that'll be 1 cosine of 30 plus I sine of 30. Now, they want our answers in rectangular format. 30 is on my unit circle, so I don't need my calculator. So this is going to be 1 times cosine of 30 is square root of 3 over 2. And the sine of 30 is 1/2. And so there's my first answer. I really don't need that 1. So there's my first answer. That's the first one. I've got to do 3 of these. Okay, so now we'll do the second one. The second one, I'm going to do the cube root of 1, which of course is 1. And I'll do cosine. This time I'm going to do 90 plus 360 divided by 3 plus I sine. What is 90 plus 360 divided by 3? Well, that's going to be 150. So I'm going to go ahead and just write the 150. And again, I know the cosine of 150 because it's on my circle. The cosine of 150 is negative square root of 3 over 2. The sine of 150 on my circle is 1/2. So there's my second one, again, in rectangular. Then we'll do the third one. The cube root of 1 times cosine of 90 plus 360 and 360 again. So that would be 90 plus 720 divided by 3. I sine And that number is going to be 270. So I'm going to go ahead and just write 270. That's 270. So I have cosine of 270 plus I sine of 270. Again, 270 is on my circle, so I don't need my calculator. I'm actually going to do the cosine of 270. And if you think about it, the cosine of 270 is 0. The sine of 270 is negative 1. So this is going to be 0 plus negative 1i. So technically that's my third answer. So that one, because of the 0, I don't need it. So my final answer might look more like this. The square root of 3 over 2 plus 1/2 I, negative square root of 3 over 2 plus 1/2 I, and negative I. Those would be all the complex roots of 0 plus 1i. All right. Remember, when you're doing more than cube roots, like if we were doing a fourth root, just so I don't have to completely do a whole nother video or a whole nother problem, just think about the formula. If I was doing fourth roots, this number right here would be 4. This, of course, would be a 4. We didn't talk much about that, but I want to make sure you picked up on that. If we were doing fourth roots, then that would be 4, and we would be doing one more. We would have one more to have to do. It's just math, y'all. Good luck with this.